Hello, I'm Brian Farrell, and welcome to PACE IT session on Storage Devices, Part 1. We're going to be talking about types of storage devices, and then I'm going to dive into SCSI storage devices, and then we'll talk about RAID. Now, I have a whole ton of information to cover, so let's go ahead and get right in. So we'll truly begin this session with a discussion on types of storage devices. First up is the traditional internal hard disk drive. It's the spinning platter type of hard disk. It had two types of interfaces. It had the parallel AT attachment interface, the PATA interface, and the SATA interface, serial AT attachment interface. These are still very common in today's computers. Then we move on to the more non-traditional types of internal hard disk drive. There's the solid-state drive, the SSD. There is the small computer system interface drive, the SCSI drive. And then there are RAID systems. Now I need to cover this, but you probably won't find these in a modern system, and that is the floppy disk drive. Floppy disk drives were first commercially successful with the 8-inch floppy. Now it is extremely obsolete now. It was replaced by the 5 1/4-inch floppy disk drive. But it too is also obsolete. It was replaced by the 3 1/2-inch floppy, the most successful of all the floppy disk drives. Now they're not very common now, but you may still come across one in the workplace, so you need to know about them. They had a maximum capacity of 1.44 megabytes. So now let's move on to the CD-ROM, the compact disc read-only memory. When these first came out, they commonly used the PATA interface, but now more than likely you'll find them with the SATA interface. The CD-ROM has a maximum capacity of 700 megabytes. Originally, CDs could only be read from and not written to. But as technology advanced, guess what? Things changed. Now, a CD-RW is a combo drive, also commonly known as a CD burner. It allows for writing data to the CD. And of course, technology marches on, and we came up with the DVD-ROM, the digital video disc read-only memory. Now, it has a maximum capacity of 4.7 gigabytes in its single-layer format, and 8.5 gigabytes for a dual-layer format DVD. Now, DVDs also came out in the DVD-RW. Just like the CD-RW, it's a combo drive that allows for writing to the DVD. Then we have the BDR, the Blu-ray disc read. Its common internal interface is the SATA interface, and it has a maximum capacity that ranges from 25 gigabytes to 128 gigabytes for a 3-layer BDR. Now, a BDRE is a combo drive that can write and erase data to the Blu-ray disc. Now let's talk about some external storage devices. As a general rule, all of the internal storage devices are available for an external connection. The only difference is that the interface tends to be different. Now, common external connections can be made through USB, Universal Serial Bus, or FireWire, the IEEE 1394 standard. And now we have what's called eSATA, External Serial AT Attachment, that some devices may also implement. Other types of external storage devices would be the Network Attached Storage, the NAS. There's also the Storage Attached Network, the SAN. More than likely, you will not find these in your average small office, home office, but you can find them in the enterprise environment. Then there are also cloud storage solutions, which tend to be a type of storage attached network. And as a rule, these all involve transferring your data over Ethernet. Now let's move on to SCSI. So we get to talk about the Small Computer System Interface, SCSI, and it was standardized in 1986. Now, SCSI was not very popular in the home market because SCSI devices cost more than regular devices, and they are a little bit more difficult to manage than your standard storage device. But SCSI was very popular in the enterprise market because the devices were very robust and could be easily, well, fairly easily, chained together. When devices are chained together, the last device in the chain needs to be terminated in order to stop signal bounce. In order for the chain to work, the last device needed to be properly terminated. Now, SCSI's longevity has led to different versions being on the market at the same time. Another thing that you need to know about SCSI devices is that many of them were hot swappable, meaning that the system didn't need to be shut down in order for a defective device to be replaced and/or for a new device to be added into the chain. Now, there are two main iterations of SCSI. There's narrow SCSI. That means 8 total components could be chained together, 1 controller and 7 devices. And then there's wide SCSI. That's where 16 total components could be chained together. Again, 1 controller and then 15 devices. Now let's move on to RAID. RAID stands for Redundant Array of Inexpensive Disks. Now, RAID is taking multiple disks or storage volumes and combining them to achieve performance gains, or fault tolerance, or performance gains and fault tolerance. The first RAID that we're going to talk about is the RAID 0, also known as a stripe set. Now, this requires a minimum of 2 volumes. Data is striped between the drives. Write a block of data to one volume, then write the next block of data to the other volume. Now, RAID 0 offers the best performance out of all of the RAID types in most situations, but it is not fault tolerant. And what that means is that if one drive fails, the whole stripe set is ruined. To combat that, RAID 1 was developed. Now, RAID 1 is also known as a mirror set. Now, it too requires a minimum of 2 volumes, but the data is mirrored between the 2 drives. The system writes each block of data at least twice. Now, RAID 1 offers extremely fast read times, but it's relatively slow in the write time as it needs to write twice. But it is fault tolerant. If one drives fail, the data is still safe. In an effort to improve RAID performance, RAID 5 was developed, and it can also be called striping with parity. Now, RAID 5 requires a minimum of at least 3 drives. In a RAID 5 setup with 3 volumes, it stripes data across 2 drives and adds a parity block to the 3rd drive in a rotating manner. The parity block adds fault tolerance to the RAID. If any one disk fails, the data can still be rebuilt by combining the data on the other 2 disks and combining it with the remaining parity blocks. Now, RAID 5 is not as fast as RAID 0, but offers better performance than RAID 1 while still providing fault tolerance. Now, if you have the ability, you might want to implement RAID 10, which is also called a stripe of mirrors, or it is sometimes referred to as RAID 1 plus 0. Now, that requires a minimum of at least 4 volumes, and it involves a mirror set that is also striped. Next to RAID 0, it offers the best performance, but it also offers a high degree of fault tolerance. Now, that concludes this session on storage devices. We talked about types of storage devices. I briefly covered SCSI, and then we went into RAID a little bit. Now, on behalf of PACE IT, thank you for watching this session, and I'll do another one soon.